Good morning, everyone. Franklin, who asked me to be the moderator for today, and if I could find someone who would speak to do so, and so I picked one of my. No one volunteered at the time, so I picked one of my talks, and this talk was given on the 100th anniversary of Einstein's paper on relativity, and it was the scientific meeting was sponsored by the country of Spain, and it was held in the Canary Islands at a university there that had the facilities to allow an international conference to occur. And I was an invited speaker, so they paid my expenses to go and to stay there for a week. So you'll see this morning here one of those one of those talks that I gave at that conference. So at this time I will go ahead. I always like to let everybody know the other people. So I'm wondering if each of you would give a little bit of your background so that the others will know who you are. So I'll start with you, Bob Gray, if you could do that. No, he just got out. Gene, then, can you tell us a little bit of your background so we get to know who we're talking about? Mm-hmm. How about James Keene? Can you tell us your background? I mean, you spoke here a couple of weeks ago.
Okay, I'm the editor of Journal of Binary Mechanics. It's a free online physics journal that specializes particularly in particle physics, and director of Binary Mechanics Lab, which is located in Dominica, where I reside at the moment.
Okay.
Yeah.
Michael, can you give us a little introduction to yourself?
I graduated from Boston University School of Medicine with an MD degree. In college, I had majored in chemistry. On graduation, I had received a membership in the American Chemical Society, but I switched to medicine, which I did for about 30 years, and then I retired from that. And since then, for about 20 years now, I've been exclusively studying ether theory, and I have my own ether model, which I think is very compelling and so on, but it's like a different ball field from what you boys do, which is quantum physics. I do like to keep track of quantum physics because I have to correlate it with my ether model. So that's why I'm so interested in your presentations.
Yeah. Michael, my work in electrodynamics and tried to show that it's the universal force. That means that all medicine can be done electrodynamically, and I'm involved in that. And I produce a experimental life energy meter. It's for sale on the internet, made by a company called Helionosis, which is in Canada. And I'm involved in electrodynamic methods of curing. There's over 92 diseases that can now be cured entirely without any pharmaceuticals or medications, just with electrodynamics alone. And that includes cancer and many other diseases. And I was not the first one to do this. It was a man named Anton Prior in France. But it's all over the internet if you know how to find it. They show you all the apparatus and everything we made. Okay. Is Gene back? Okay, well, we'll go ahead and start then. I'll begin the presentation. Let's see. This presentation is called A New Foundation for Science. I'm a person that likes to get involved in things that are very significant. And so this is the talk I gave at, one of the talks I gave at the International Scientific Conference in the Canary Islands in 2005. This foundation in science was triggered by the work of Nobel Prize winner Arthur Compton and one of his graduate students named Winston Bostick. And Winston Bostick discovered that one can manipulate the electromagnetic field and produce a standing wave, which is shown here on the right. Yeah, this is a standing wave, and it's in an electromagnetic field, and it's made by disturbing the field. And Winston Bostick found this, and he was able to make them of various sizes. He found they were extremely strong, and if he put a metal prong in the center, it would stay near the end of the metal prong, and then he could put that prong into a nuclear reactor where you had fusion reactions going on, and all the material holding the reactor would slowly deteriorate over time. But this toroidal ring, called the soliton in the electromagnetic field, was not affected. It was stronger than any known material that man had ever found. This is a cross section of it here. There's actually, it looks like a current flowing around. First of all, it's going around the circumference of the ring, but it's also going around the cross section of the ring as it goes around. And this produces basically what looks like a Coulomb electric field with a magnetic moment and also a spin. The spin is the part around the cross section. Magnetic moment is the part around the whole circumference. And so this is what is changing all of modern science, our discovery of this. What are the problems with modern science? Why do we need a new foundation? The problem seems to go back to Thomas Aquinas, and he developed a wrong criteria for truth. And he did not use the logical consistency and combine that properly with empirical confirmation. And this was the way that he approached things, was not a criterion that could give rise to real truth. If we look at how many theories we have to describe matter, there are electrodynamics, classical mechanics, quantum mechanics, special relativity, general relativity, Dirac theory of the atom, nuclear shell theory, which is quantum theory also, quantum electrodynamic theory of elementary particles, theory of universal gravitation. All of these theories. The proposed simplification is that everything is built, all forms of matter are built from this electrodynamic soliton that Winston Bostick and Arthur Compton discovered. And these combine together with geometry to make everything in every field, whether it's living cells, geology, or astronomy, or chemistry, or physics. The problems with modern science can be expressed in a number of ways. One is most fundamental theories are too complex. For instance, there are more elementary particles, over 500, than elements. Well, when we first invented the theory of the atom, and we thought, oh, we got it. It's a proton, a neutron, and an electron. And now we can explain everything in terms of three elementary particles. But no, not anymore. It's over 500 elementary particles and only 109 elements. And there are too many exceptions for each theory. Electrodynamics, for instance, is not valid on the elementary particle and atomic scale. If an electron orbited the nucleus, it would have to give off continuous radiation, but it doesn't. So all these rules in electrodynamics that we can confirm in accelerators and that sort of thing, they don't. They're not properly covered. And electrodynamics is invalid at high velocities because of relativity theory. Mechanics is invalid on the elementary particle and atomic scale. We have point particles, and we don't have conservation of energy and momentum, and things are occurring too fast for time. And so we have all of these problems with our various theories, which we've never been able to resolve. And there's too many logical inconsistencies within and between theories. In other words, one theory is not compatible with another. And there's an emphasis on mathematical theories, more emphasis on that than physical theory. So mathematical theories are represented by things like quantum mechanics, which doesn't have a proper physical basis. And also the notion of cause and effect is lost in modern science. So we find a failure of the fundamental theories to correspond to reality. Elementary particles are falsely treated as point light. It does not agree with experimental data. Causes science to be based on random statistical processes, and there's no law of cause and effect. So we've got these problems, and we're not going about them the right way. Let's look at problems with special relativity theory. It is based on the point particle assumption. It is inconsistent with the laws of electrodynamics. It has an inconsistent internal set of assumptions. It fails to explain Doppler shifts in the Fizeau experiment incorporating the extinction effect. It fails to explain drag aberration of starlight. It cannot describe elastic systems. It omits the effect of acceleration, A equals dV over dt, and radiation emission and absorption. It omits the effect of radiation reaction, the dA over dt, where A is acceleration. Derivations of Weber's law show that special relativity theory is just a mathematical approximation to the velocity term in the Galilean transformation for finite-sized particles. So we see that the old version of electrodynamics we had, Weber's version, tells us a little better what's going on than we get with our new theory of special relativity and the Maxwell's equations and that sort of thing. Now, we want to see the superiority of electrodynamic explanation of relativistic effects. If we look at Ampere's law, it includes both lab and rest frames. This is the generalized form of Ampere's law. See the R and then the R prime. So that's your two frames of reference. Faraday's law also involves lab and rest frames. You can see the primes here and the unprimed. So, using the Galilean transformation of Ampère's law, the fields of a moving particle are E equals E naught times 1 minus v squared over c squared divided by 1 minus v squared sine squared theta over c squared to the 3/2 power. You can see there is more detail here than in special relativity theory. And this agrees with the data in electrodynamics. So we see some of the problems coming. A new foundation is based on logical principles and criteria. It is based on classical electrodynamics of finite-sized particles, no point particles. It is based on experimental measurements of size and shape of elementary particles. It is based on extreme ultraviolet atomic emission spectra. The current theories of the atom, including the Dirac theory, cannot explain one emission spectral line in the extreme ultraviolet for one atom. But we measure hundreds of them for every atom. How can we elect a theory in that misses half of all the spectral lines of every atom? Somebody's promoting political correctness, not agreement with data. Based on solitons of the electromagnetic field in the shape of a toroid called a monad by the ancient Greeks, that this is going to be the new foundation for modern science. And we are going to look at the role of logic a little differently than we have currently. We currently have the existential scientific method, and then that's been replaced more recently by the postmodern scientific method. Both of these methods do allow false postulates or assumptions in any theory, but they shouldn't. They don't require the theories to explain all the relevant experimental data, just some data. This scientific method does not require all theories to be self-consistent with other theories, one another. And all the theories should acknowledge that all particles in the universe interact with one another in a self-consistent way. But that self-consistency is not there in the existential and postmodern philosophy of science. Now, the person who made the biggest impact on science in Europe at the turn of the century, beginning of the 20th century, 1900s, was a fellow named Henri Poincare. And here he developed a new area of philosophy. Is called meta theory. And meta theory is the theory of theories, not atomic theory or nuclear theory or quantum mechanics or something like that. This is the philosophical area where the rules for all theories are developed, whether it's in mathematics or physics or whatever. And so the first one of these that Henri Poincare proved was that no two fundamental theories may use the same fundamental constant, such as C. Well, if we look at electrodynamics, it uses C. If we look at special relativity theory, it uses C, and E equal mc squared. If we look at quantum mechanics, it uses C in E equal h nu or hc over 2 pi lambda. If we look at general relativity theory, it uses C in the definition of GIK. And the Poincare's logical criterion requires that electrodynamics alone explains all of the theories above, or all of them are false. All of them, all of these theories are false. Because by logic, no two fundamental theories can use the same fundamental constant. Because if they do, they're not fundamental. And so what we see is that all these theories are bad. And the solution, the simplest solution, is to revise electrodynamics so that you don't need any of these other theories. And it turns out that all you have to do to revise electrodynamics is to solve the 6 empirical equations of electrodynamics simultaneously, and you've got it. But when Oliver Heaviside took Maxwell's place, he got rid of 2 of the fundamental equations of electrodynamics and used only 4, and made a few assumptions to get rid of some of the extra terms he couldn't explain. And so you could get a solution with 6 unknowns and with 4 equations. And so that's how we got started on this path. Now, if we look at, we're going to look at elementary particles, atoms, and nuclei for just a moment here. If we do hard X-ray and gamma ray scattering on atomic electrons, we can see from the scattering the ring shape of the electron. And it's not orbiting the nucleus, it's fairly stationary. And so, but do we acknowledge this in our textbooks? No. Do we allow people to publish papers on this now? No. But the work has been done, and it's been done in all kinds of laboratories around the world, but it's not politically correct to tell anyone about it now. We also have the fluorescence absorption of X-rays on atomic electrons, and that shows the ring shape of the electron. The electron scattering on the proton and neutron show finite-sized substructures. We call those quarks, but quarks are made of something smaller than a quark. And we'll see what that is. And plasma injectors show that the ring of an electron is composed of multiple solitons of similar size. And it turns out there's 3 in the electron. Each elementary particle has a finite number of these, and they can vibrate back and forth, the solitons, and that, when you use the equation E equals mc squared, that shows you that the energy of the vibration predicts the mass of the particles. Okay. Bostic's plasma experiments on plasmoids show that how they are constructed of uncuttable charged fibers. These are continuous. It's not like a whole bunch of particles moving around in a toroidal ring. It's a single entity, and it has tensile strength, and you cannot cut it. And the work that I've done with plasma spheres, you've probably seen these, people use them just for fun, show that there are charged fiber structures to at least 3 levels in the most fundamental structures. And so it turns out that one can predict all of the properties of all of the experimentally verified elementary particles. There are 96 of those. One can explain all of those by using the 3 levels of charged fiber structures. And you're able to predict the mass, all the decay modes, and the decay modes have to conserve the solitons. You can't create or destroy a soliton normally. So what happens is if you have a particle like a neutron that decays into a proton and electron, other things, you must account for every single soliton. And we're able to do that. And so that's amazing that we can make that progress. Okay. Colwick, William Colwick, who was at University of California at Berkeley, predicted that magnetic flux loops move with electrons in a current. William Hooper also went to University of California, Berkeley. He confirmed experimentally that flux loops move with the electron drift velocity, implying that the B cross B field in electrodynamics is not electrostatic. So a lot of people just treat all electrodynamics as electrostatic, but it's not. Moon and Spencer, who were at MIT, they showed that induced fields do not obey the superposition principle in validating Heaviside's version of Maxwell's equations. And the idea that the electric field is an extension of the charge and therefore electric forces are contact forces can be shown from experiment. So we've always talked about action at a distance and contact forces. Well, it turns out that the electromagnetic field is everywhere, but the source of the electromagnetic field is not charge. That was an approximation that we made experimentally when we were making our empirical laws of electrodynamics. But it's a good approximation for most experiments, so we use it. But it's the solitons in the electric field that produces what we call the charge and determines its size and all that kind of stuff. And the charge, the size of the soliton can be quite different. It can be macroscopic, easy to photograph, or it can be microscopic, the size of an elementary particle. And so those are all the things that we get from this work. Now, if we do electron scattering off of a proton, we'll see there's a bump here and a bump here. And then if we do it off of a neutron, and it's kind of hard to see the thing underneath here, but there's a bump here, and then a bump here, and then another bump out here. So when we look at those, we say, oh, those substructures are quarks. But they are also, the quark can be defined in terms of the solitons. And each quark has a unique structure, and it has a spin and mass and all that sort of thing. And all of that can be predicted from the soliton in electrodynamics. The soliton, or what was originally called the monad by the Greeks. And by the way, I don't know if you know where that term comes from, but the Greek historians say that Moshe, or Moses, the Jewish Moses, who was a lawgiver, who was educated in the palace of Egypt, he is the one that first expressed this idea of monads, and there were only two types of monads, a monad and anti-monad. And today, with the things we have, we say that a monad is consists of the net charge of plus or minus E over 3. And in primary, you can build structures that are bigger and make use more solitons in them. And so that's where that comes from. And by the way, not only the Greeks give Moses the credit for that, but the Jains of India also do in their ancient literature, which is from before the time of Christ. And so we see a lot of information that's no longer included in our textbooks because we have rewritten the history of science, starting with people like Democritus. But that's not the way the Greek philosophers did it. And also, if you remember, the Greek philosophers over their academies, which is like our universities, they had a sign, "Let no one ignorant of geometry enter here," because they believe that the geometrical combination of monads was the key to all matter and all structures in matter. So each soliton has a helicity, and combinations of solitons have unique angular momentum and different properties. And there's a soliton ring model conservation law, and it says each soliton pattern is conserved in all particle interactions and decays. These patterns correspond to the standard model of elementary particles in terms of quantum numbers plus new quantum numbers. And neutrinos and neutral pions play a significant role in conserving angular momentum. Each soliton loop is conserved in all particle interactions and decays. Note that the standard model of elementary particles only conserves net charge, not total charge. So if we had 3 plus and 2 minus charges in a particle, it would be a plus charge of 1. So that's how the standard model works, and that's not the way the experimentalists see it. And so we have to use quantum mechanics to get some new particles out of the vacuum. Otherwise, we can't explain what's happening. Okay. The mass or total binding energy of an elementary particle increases, according to the soliton model, with the number of primary, secondary, and tertiary solitons due to the 1/r² factor in the binding force holding solitons together. So solitons, even though they're made of the electromagnetic field has tensile strength, and this tensile strength can either repel or attract. And remember that the soliton is like a magnet too. So not only does it have what we call Coulomb attraction repulsion, it's also got magnetic. And the magnetic is very strong at short distances. Now, when we have a particle, a soliton, and we have some additional energy coming in from the left here, say a beam of light, it can be absorbed on the soliton ring, and when it does, it makes an additional standing wave in the soliton. And if that soliton releases it, it comes off as light and goes back to the original state. So this is what is happening in the atom. The electrons are made of solitons, and they can absorb light and emit light. And so, and we have, without orbit, we don't have to change orbits of the electron. All we have to do is let the electric field give off some of its energy as emission, emitted light. And when we look at the wavelength, we have a difference here between the soliton and electron particles. And that is, the wavelength can be the circumference of the ring divided by n, or it can be n times the circumference of the ring. And so we see the wavelength, and we see how one ring can hold all the different emission states of an atom. We don't have to have an electron make a transition from one shell to another shell to give the electron orbit of the outer shell is bigger than the inner cell, so it can give off some light when that happens. That's not what occurs. And if it did occur, then in addition to that light due to what we see there, because the electron is accelerated, it must give off another type of light, which is not observed. And but in an accelerator, if we have an electron beam going in a circle and we reduce the size of the circle, the electron, as it's or accelerate faster or whatever, it's supposed to give off light in addition to the light due to transition, and it doesn't do that. And so the current theory of the atom ignores the laws of electrodynamics, the empirical laws that we confirmed by experiment. Okay, in the Soliton model, we only have electrodynamics. So gravity, it turns out gravity is a force between oscillating solitons. And that gives that, you can calculate that force and you can get big G and all of those fundamental constants that we have with our theory of gravity. You can get that. And not only that, you can predict that you don't need dark matter and dark energy because you get a different form of the force of gravity that takes into account what we invented dark matter and dark energy to explain. So we had Pioneer 10 and 11 showing that the gravity from our Einstein's general theory of relativity and Newton's universal law of gravitation is invalid as you go out from the sun further out. It predicts that properly, and it also predicts the spiral arms, the faster speed of the spiral arms of outer spiral galaxies properly. So you don't need dark matter and dark energy, but with the current theory of gravity we need dark matter and dark energy, and we need 94% of the universe dark matter and dark energy, and 4% or 96% dark matter and dark energy, and 4% regular matter and regular energy. So we see all these exceptions that we made are not needed. So now, in the Soliton model, the scale of laws is such that the laws of electrodynamics are the same on all size scales. And the laws of mechanics are the same on all size scales. So this is very interesting because now I should be able to explain the structure of galaxies. I should be able to explain atoms, elementary particles, nuclei, all size scales with exactly the same theory. And that seems to be what we can do. I mentioned earlier, gravity is due to the attraction of vibrating solitons in matter. So if we have solitons that make up the electron, and they're vibrating, and the electron's not orbiting the nucleus, but it does group itself into shells. And we'll see that in a little bit. It's that vibration which we can calculate, and we can predict the force of gravity. So that's very interesting. Now, if we compare the Soliton model with the standard model, we see the Soliton model explains all symmetries of standard model in terms of geometrical combinations of angular momentum of the solitons. But it goes beyond the standard model by explaining the internal structure of quarks and leptons in terms of plus or minus the charged soliton loops. The standard model is found not to conserve total angular momentum and total charge in various decays and reactions, but the Soliton model does. Why don't we falsify the theory? Because it fails. That's an interesting question. If we compare the soliton ring model with the supersymmetric string model, and these solitons are sort of a little bit like a string, except that so in the soliton ring model, we have primary, secondary, and tertiary ring structures with 3 spatial dimensions plus time. In the string model, we got 25 spatial dimensions plus time in order to explain the data we have. Or the supersymmetric string model has 9 spatial dimensions plus time. The soliton model explains all the fundamental forces in the unified theory with quarks, E plus, E minus, pions, and neutrinos as the soliton structures that are the building blocks of elementary particles. And we are able to predict all of the observed properties of elementary particles. And but not all those properties can be explained by the string model, supersymmetric or regular string model. There's a superiority of the soliton model because it can explain the internal structure, physical structure of observed elementary particles in terms of soliton structures. It explains the observed elementary particle decays and interactions in terms of conservation of soliton charge loops and angular momentum. It explains all fundamental forces as electromagnetic forces. It is a simple classical theory based on cause and effect. The laws of electrodynamics are the same on all size scales. The laws of mechanics are the same on all size scales. So this is where it is, the soliton model is superior to the string model. Okay. So now let's look at the soliton model of the atom. The balance of electromagnetic forces in electrons made of solitons allows them to exist in stable equilibrium positions at finite distances from the nucleus without having to orbit. Combinatorial geometry of soliton structures can predict the number of electrons that will pack about the nucleus in successive shells using the constraints of the spherical and chiral symmetry of electrodynamic force. I had my son do a science fair project on this, and he used ring magnets, which are similar to solitons, and he was able to show that the ring magnets also make the rings that we associate with the atom. And here's kind of what they look like in 3 dimensions. This is the neon atom, and that's the nucleus there. And there's a first shell of 2, and then this is the next shell of 2. And you can make these in terms of great circles and geometric in their organization. And by the way, it is this model of the atom that explains how atoms come together to form molecules. Because if they're orbiting the nucleus, how can they orbit and stay compatible and stable when the electrons have to orbit 2 or 3 atoms in a molecule? And this doesn't have a problem because they're stable enough that they can just be joined like you would join magnets together. And so that's interesting. Here are the distribution of electrons in packing shells, and you can perform experiments with ring magnets and show that all of these exist. Okay, this is the predicted distribution that for atoms. And we're going to find out in the case of the nucleus, there's something different that has to be taken into account, which isn't taken into account by the quantum shell model of the nucleus. Here's the coupling of atoms. You can see how if you just had the outer shell of 8, you could see how you take one away and bring up another one with an extra one, you can form a molecule. Like this one here is CO2. And you can see how they form a lattice structure, the kind of structure you would expect magnets to form. And that's what they do. The Soliton model shows how magnetic forces are dominant in forming molecules. The Soliton model of the atom predicts there are only 7 periods or rows in the periodic table of the elements due to the properties of Soliton rings. These larger shells that they're talking about, they don't bind properly to exist in atoms. What are the reasons for the acceptance of quantum theory? It's based on the unphysical mathematical explanations for blackbody radiation, photoelectric effect, emission spectra of atoms. But all of these are false. Emission spectra of atoms. Quantum theory can only predict half of the emission spectra of each atom. Only half. Is that a good theory? Half? No. You want a theory that predicts all. And you want it to predict it very accurately. So the photoelectric effect, the quantum theory cannot properly explain what is happening there. But the Soliton theory has no problem, and it's very physical. And blackbody radiation and all that can be explained better with the Soliton theory than in previous theory, the blackbody radiation. Here's the blackbody radiation. This line here is the actual prediction from Soliton theory. Very good. And this is at a particular temperature. So the actual blackbody radiation is done better by Soliton theory. If you look at the quantum theory of blackbody radiation, the oscillation of point electrons in atoms is too big to remain bound in an atom. The laws of electrodynamics are violated for the electron. The theory is incompatible with optical reflection, refraction, and diffraction. It ignores the finite size and structure of the electron. So we see all these problems with the regular quantum theory, but no one is willing to acknowledge that. If you go before the American Physical Society and present this, and you're working at a university, you're fired within 24 hours. They don't allow it. The superiority of the Soliton ring model for blackbody radiation, the amplitude of charge oscillation in the ring is acceptable for stable atoms. All laws of electrodynamics are satisfied. We use a realistic physical model of an electron. It's fully compatible with optical reflection, refraction, and diffraction. So here's a picture now of the how light can come in, be absorbed on a soliton, cause a new standing wave to be occurred there, and then come off and go back to the other state. If you're into radio emission and that sort of thing, antennas, you'll find that the soliton has many of the same properties as an antenna, and like a circular antenna. And so we see we know a lot more about it than we're willing to admit. Here's the photoelectric effect, and you see the predictions of the Soliton model. You know, it does very well. So here's some problems, more problems with the quantum theory photoelectric effect. It ignores the finite size and structure of the electron. It cannot physically describe the absorption process nor the physical changes in the internal structure of the electron when it absorbs energy. It cannot explain why the photoelectric effect does not occur on non-crystalline forms of metals, only crystalline forms. That was not known at the time that Einstein's wife published her paper on the photoelectric effect. They had only used crystalline forms of metal. But then when they started making it non-crystalline, they found it didn't work. And if you are into optical chips for computers and stuff like that, every optical chip that works has antennas built into it on the microscopic scale. They don't tell you that because they'll get into trouble, but that's what they do. And they had to learn to put those in and to optimize them to make optical chips work. Optical chips do not work unless you have some type of antenna to receive it. And so anyway, that's another interesting thing. Okay, let me go on a little further here. This is the Balmer emission line spectra of hydrogen. And you can see the various lines. And these are predicted by the current quantum models of the atom. But there's another part of the range over here. It's called the extreme ultraviolet. And none of the theories, none of the quantum theories of the atom predict anything over here. But here is what NASA measures over there. Can you see all the numbered spectral lines? These are just the spectral lines from hydrogen and helium. And they're all predictable by the Soliton model of the electron and that model of the atom. And when my son put his science fair project in, he got to go to the International Science Fair. And they use only Nobel Prize winners to judge the projects in physics at the International Science Fair. And this year he went to it was in Canada, Ontario, Canada. And the judges refused to judge my son's project because it falsified the work for which they received a Nobel Prize. However, NASA was choosing the grand prize winners at the science fair, and they chose my son's paper because they said his science theory of the atom is able to explain all of the spectral lines we measured in space for hydrogen and helium in the extreme ultraviolet, and no other theory of the atom has ever predicted one of those lines, or even one. And so that was what happened. Okay. The physical problems with the quantum theory of the nucleus: electrons orbiting the nucleus do not radiate light, continuously violating the laws of electrodynamics. There is no mechanical balance of forces in the atom. There is no physical mechanism for absorption and emission of radiation. The quantum theory of the atom ignores the finite size and structure of the electron. It cannot predict the observed emission spectral lines of hydrogen and helium in the extreme ultraviolet part of the spectrum. So these should falsify the theory, but they do not, because under the postmodern philosophy of science, you don't falsify theories this way. You don't use logic. You don't use this technique. And any data that doesn't agree with your theory is invalidated. So the superiority of the Soliton ring model for the theory of the atom is electrons do not orbit the nucleus, but have a continuous charge density in a closed ring. The electron magnetic forces between the ring electron and the nucleus is in balance for all states. The Soliton ring model has a physical mechanism for absorption and emission of radiation, which we saw, standing waves in the core. Also, it obeys all the laws of electrodynamics. It uses a realistic finite-sized model of the electron. It describes all the emission spectral lines observed in simple atoms like hydrogen. Now we want to talk about the Soliton ring model of the nucleus. The neutron is a bound soliton ring electron and a soliton ring proton. Okay, the soliton ring proton has, the electron has 3 rings, the soliton ring proton has more. The nucleus consists only of ring electron and ring protons. There's no such thing as a neutron. It is just a combination of protons and or solitons from protons and electrons. And the ring electron and proton shells alternate from the center outward. So if we now look at the in combinatorial geometry, you can pick the number of electrons and protons that will pack the circular shells. Okay, so let's see if I can get it now. Over here. What happens in the nucleus is as you measure the solitons, you measure the binding energy of each of the shells. And it turns out the bigger shells have a stronger binding energy than the smaller shells. So what happens is we make heavier nuclei, the interior density of the nucleus decreases because the inner shells come apart and form bigger shells, which are more strongly bound. So that is why the quantum theory in the nucleus cannot get a lot of properties in the nucleus correct. Here we see the ring model for the oxygen-16 nucleus, and the electron is the big ring, and the proton is the small ring. And notice how they're arranged here in a shell of 8 electrons and even more protons. And so we see how they come together in their balance of forces, and they're not orbiting. And now if we look at the shells, we discover that we start with 2. But as we add 6 more electrons, we end up with a shell of 8 because it's more strongly bound than a shell of 2 and a shell of 6. Then as we add more electrons, we get back our shell of 2, but we now take the shell of 8 apart and use it to form a shell of 18. So in the nucleus, we don't go in this order in making the shells, and they don't stay stable. They come apart. And so you can see the various nuclei here. And it is this property of the nucleus that the Soliton model is able to predict that the quantum shell model and the liquid drop model cannot do. Now here is the various shells that are formed about the nucleus for lead-208. Notice that the dashed line is the electron shell, and the solid line is the proton shell. And they're alternating, starting from the interior of the nucleus on the way out. But at one point, we get to the point where we have 2 proton shells, and they repel one another, and they cause the outer electron-proton shell to be like a liquid and to have the properties of a liquid. and that is the origin of the liquid drop model. It tells you why that works. And you can see, and you can predict it directly from the Soliton model. The quantum shell model fails to predict the nuclear spin for 347 nuclei, and they're shown here. There's the atomic number. And guess what? The Soliton model predicts every nuclear spin ever measured. 2,870 or something like that. It predicts correctly. None of the other models do. But they don't emphasize this. The fact that the current theories of the nucleus cannot predict this data, we don't falsify them on that basis. We just make additional terms and we try to do other things to account for this data, which is not predicted by the theory. So the superiority of the nuclear soliton ring model over the quantum shell model. It predicts the correct spin of all 2,870 nucleus. It predicts no stable nuclear shells larger than 50 neutrons. It predicts, the model explains the physical basis of the nuclear liquid drop model. And it explains the decreasing nuclear charge density with heavier nucleus. In other words, those internal protons and stuff came out of the smaller shells and joined larger shells where they were more tightly bound. That's it. So at this point, we'll now open the floor for questions and comments. And I hope you kind of get the idea that there's something wrong with the politically correct theories that we are teaching in our universities. And they don't follow any good rules. They don't use data to falsify them. They don't use logic to falsify them. And they just use some data that agrees with them to support them. And that's all that they do. Okay, let's see if anyone's raised their flag who would like to ask a question. Or you can just turn on your microphone and ask a question and make a comment. Okay, Michael?
Well, in the course of your discussion...
Yeah, go ahead.
In the course of your discussion, you mentioned that there was a vibration in the solitons. Part of their dynamic involves the vibrations.
Yes.
And also that they are considered to be building blocks of quantum units. Well, in my ether model, I happen to use both of those. Only I use the concept of vibration to confer linearity and a continuum of forces, which gives you a more simple, actually more versatile, basic model, very fundamental model for the orderliness and the stability of quantum systems, such as atomic structures, which I think require, linearity, continuum, very simple underlying controlling forces to account for that. Now, that's in my model, because I don't, there's no geometry involved. It's just linearity and continuum of forces. And
right. Well, I think if you see this this approach that's based on electrodynamics being the universal force, the only force, and based on the only structures that electromagnetic field allows, because it has tensile strength and continuity. You can't cut it in half or anything like that. It's able to predict all of the various atoms and nuclei that can be observed. It also predicts the what are called islands of nuclear stability. And many of those islands that we have observed cannot be predicted from the quantum shell model, but ours not only predicts that, but it predicts more that have not yet been observed. And so one of those has been observed since that time, and the fellow who was working on it at the Louisiana, University of Louisiana in New Orleans, when he published the paper showing that one of the predicted islands of nuclear stability had just been observed, he was fired from his job. And I'm sad to say I don't think he's been able to get that back. And so another fellow who worked with us on that was at University of Virginia in the nuclear physics department, and he was told, do not ever come back. You cannot come anymore. He is retired. He's an emeritus state. And they told him, you can't come back to your office. You cannot come and speak on the campus. We don't want to ever see you again. That's how bad political correctness is. When you show something, you prove something that they don't like it.
Well, I just think that when you bring in the concept of vibration, that's a different dynamic, a different mechanism than quantum dynamics, and that you have to separate the two.
Because, they are separated because one is the quantum dynamics is when you have light coming in, like in the photoelectric effect, it has to be absorbed and on an electron, a soliton, the three solitons that make up the electron, and then it gets emitted. And there's a slight difference between them, so you can actually see some small effects that have been given other names. And but I think there's a lot in common between our various approaches, and when we see success for one aspect, we think that's great, because the other theories that are politically correct can't do that. And but the question is there more? And that's where the role of logic comes in, and that's where people like Henri Poincare made a big impact on the world. I want you to notice that Einstein did not receive any recognition for his theory of relativity in terms of what do you call it? Not the Peace Prize, but what's the highest award we have in physics? Anyway, his wife received it for the photoelectric effect, but he did not. And that was due to the work of Henri Poincare, that he never had the approval of Henri Poincare, who had disproved it. He, of course, had published the paper first, and then he had disproved it. And you may not realize it, but if you go to a library, like I live near, I went to school at University of Maryland, and I know the library in there very well. And in their card catalog, they have the books, papers of Poincare that proved the various theorems of meta theory. And I went in and I talked to them. I said, well, it's not on the shelf. Who has it checked out? And the librarian, who was a friend of mine, said, it's permanently checked out. It's in a safe and locked, and no one is allowed to see it. He said, we're required by the Department of Education to do that. They have the education framework does not allow this to be taught or seen by anyone at any university that receives federal funds in the United States. So then I got my friend from Brazil to go over to France, and where Poincare lived, and to see if he could get it from the library there. And he said, no, they won't let you see it. But he said, if you can find someone with a private copy from that time, 1900 or 1915 or whatever, then you could get it that way. So I have gotten a few things that way, but not much. They don't want you to be able to see any proof of theorems and validate their theories. But that's the politically correct parties. So be careful. And I wish to say I was fired from Catholic University for revealing some of this information. And I know in the NPA, we used to have up to about 500 people who lost their positions in universities in the United States of America because they discovered one or more of these things. I used to talk to them. So it's a shame that happened. Other comments, discussion?
Hi, this is Jim.
Uh-huh.
I made some notes during your talk, Bill, and there's a whole lot of areas where it seems your work is very consistent with my work in binary mechanics, and I find your work extremely interesting. But let me just focus for now on just one simple question. You're saying the electron soliton has a finite size. What would that size be? Because in my work, I give you in size.
Well, the size for a, it's temperature dependent, but if you measure it at low temperature, it's the circumference of the soliton is the wavelength of the electron.
Well, I'm looking for an answer in meters.
Oh, well, what we Arthur Compton received the Nobel Prize for that work, and I don't have the number right in front of me, but the wavelength.
Okay, I've got a radius of about 0.816 L units, and the L value is about 2/3 of a femtometer.
Yeah, I guess you're aware that the international standards just changed in the last year or two.
The international standards for what?
All of physics.
All of physics.
Yes. It was done.
No, I'm not aware. I guess I'm not aware.
I just happened to catch it on the news. I was just watching one of these news stations on TV, and I saw that, and I said, well, that should be in the newspaper and all this stuff, but.
Oh, you mean how they set forth the so-called fundamental constants of physics, such as at usnist.gov, all the constants, that you can download in a text file.
Yeah.
That's what you mean.
Right, and
well, then I'm aware of that. Yeah.
Yeah. Okay. The thing that in my work, if the electrodynamic force is the universal force, then I should be able to predict all the fundamental constants in physics. And
I'm going to since last week I did some homework and I watched the video on the CNPS site of your award-winning presentation where you were given a Lifetime Achievement Award by CNPS.
Oh, yeah.
And in there, you're deriving the constants. But I wanted to clarify that, since you brought it up just now, that in fact, you're not deriving the constants entirely from first principles, because in every single case that you showed in that video, C, which is a measured value, that's not a first principle, it's on the right side of the equation.
Yeah.
So that confirms my claim, anyway, that I'm deriving those constants from first principles. What you have done is shown, and it's I don't mean to diminish it, but it's you're showing relationships among constants, which other physicists have done as well. So, but yours, I'm particularly interested in. They seem to be somewhat more advanced. But you do have C and other constants on the right side of the equation, which are not first principles. They're measured values. So you're not really deriving from first principles entirely those constants.
Actually, I should make this comment. The work that I have done is based on the 6 empirical equations of electrodynamics.
Understood.
Okay, so now they are defined in terms of C, and C is a measured value. But
it's not. It's exactly. So you're really not deriving them from first principles because it's a measured value. Now, for example, I'd be interested to find out what would happen if you plug in my value for C, which is the bit velocity divided by pi, in your equations, and what's going to happen there. In other words, I think your work, and I could tick down a whole long list here that I made notes during your presentation today. Like you talk about a lattice structure, you talk about fractional charge as E divided by 3. The soliton seems to be equal to a spot in my work, and the finite size of the electron and so forth. Really, I think your work should be somehow linked with my work. And I don't know who would have the motive to do that. I would, perhaps you or other people. But the first thing you need to do is to get rid of C on the right side of the equation, because it's not a first principle. It's a measured value.
The approach I'm taking, which was kind of following in the wake of Henri Poincare, is I'm trying to combine the empirical and the logical approach to science. And so I don't use ideas other than what have been expressed in empirical laws. And the empirical laws we know are imperfect because we know that charge is not a quantity. Charge
is not a what?
Charge is not a physical thing because the soliton consists only of the electromagnetic field. But using the field, we can approximate the field of the soliton with a charge. We approximate it, but it's not. The concept that we have with charge is kind of like when we wrote down F equals ma. Well, we knew the force was proportional to acceleration, and we put a constant there, and we finally gave a name to it, called it mass. But that didn't tell us what mass was. And
yeah, what you're saying right now, if I may be so bold, is you're saying the quantization of mass or energy, length, space in terms of a length constant, and time in terms of a time constant are required. You're giving the argument for binary mechanics, in other words, because approximations in physics are they're not good enough, quite frankly.
Yeah, you may be right about that. And what I'm just trying to say is that I followed the approach that was outlined by Henri Poincare as accurately as I could, and I've had wonderful success. But the job is not over. In other words, if you can explain more than I've explained from those empirical laws, like the empirical laws have charge in them, but we know that charge doesn't exist because you can't separate charge from the electromagnetic field. And so
well, of course, in binary mechanics, I do. There's a separate bit operation for time development for the scalar or electrostatic potential based upon charge, and which are the M-type bits, and the magnetic or vector potential, which is based upon the L-type bits. Now, I'm not diminishing your work. That's why I'm so fascinated by it, because the fact that you seem to have taken two of the three forces that I define, the scalar and the vector, and not taking into account the strong, but those two, you seem to have predicted a whole bunch of observations, which is phenomenal. I mean, this is absolutely sensational work that you've done, in my opinion. So, because it is so sensational, predicting these spectral bands and, well, God knows, all of the things you just presented, a myriad of things, is sensational. So I would like to see how that is related to my work with the full quantization. That's all. And like, for example, every time you've got C on the right side of the equation for a fundamental constant like charge or whatever, you did present in that other video I mentioned, what if we plugged in bit velocity V divided by pi? Then you've got first principles. There are no measured constants in your work.
Right.
And we can then go from first principles to all of the truly incredible predictions and explanations of observed data that you have done. Sorry, I don't mean to lecture. I'll be quiet. But that's sort of the gist of my take on your work. It's all applause. I'm not sitting here trying to criticize anything. I'm trying to see how it's related if you get rid of measured constants in your equations. Because measured constants are observations, they are not first principles of a theory.
I guess you would say first principles are assumptions. And how do you verify an assumption? You can only verify
observation
by certain things, so what my goal was to make the theories in science that I'm working with compatible with all the known experimental data and logic. But as I pointed out, the known experimental data does not know, built into the equations, what mass is or what charge is, and that sort of thing. So the only notion we have is that the field seems to be the universal thing, and
see, but the field is based upon, if I may interject, sir, classical continuous space-time theory, okay, where position and so forth are real numbers, okay, and so you're basically talking about, like, presumably in any volume of space, you have an infinite number of field encoders, we might call it field encoders, which are there, and they're all infinitely small. In other words, it's based upon a miracle. And belief in a miracle. And so therefore, that's why I argue you've got to quantize the units of measurement. And all of the parameters in those 6 equations that you used are expressed in terms of mass, length, and time, the units of measurement in physics.
Yeah.
So once you quantize energy, and you can do that in terms of mass, which can be converted to electron volts, for example, space as a length constant, time as a time constant, and that is again a first principle. Okay, and you can come up with actual values for m, l, and t, which are your units of measurement in physics. But that doesn't contradict anything you said in terms of being able to predict things with your analysis, which is totally sensational. But I'd like to get the foundation of it. Remove measured constants, so you're really saying, I can predict all of this data from first principles alone. without any measured constant. Okay? In fact, I can predict the measured constants, as I showed you 2 weeks ago, predicting the speed of light based upon only first principles. No measured constants. And we measured the speed of light as bit velocity divided by pi. Because the bit operations are first principles in binary.
Yeah, but we have no way of confirming the existence of bit velocities, do we?
And what are you doing?
Listening to the last conference.
Yeah, then?
I'm going to work on this.
Then I think you got to run over to Cole's before she gets down here if you want to look at a white shirt.
Oh, it's not, I guess it's not necessary, but it is. I guess I'm going to get $10 off.
But I like the approach that you're trying to do, and I think we need to learn how to communicate a little better on that, because what were the constants in these empirical equations, by using electrodynamics, I'm able to derive like F equals ma, and the force of gravity is equal to big G m1 m2 over r squared. I'm able to derive that electrodynamically and show what the definition of mass is, but not charge. And so anyway, there's frequencies in there of vibration.
Okay, I've derived electric charge and fractional charge based upon the scalar bit operation, which is your electrostatic effect. Okay. Again, I'm not minimizing your work. As a matter of fact, because your work and what you're able to predict based upon your line of thinking is so sensational, I would just like to see how, take out the measured constant. Yes, these guys that came up with your 6 equation, a century or more ago, Maxwell and the rest, were great workers, and they used measured values in their expressions and so forth. But that was 100 years ago. Now, to get the first principles of everything, including what you've derived.
If you take out the measured constants, all you're left with is relativity.
Okay, does anyone else have some other things you'd like to talk about? I'd like to just mention this only covers a certain amount of science. There's biology, and there's the origin and nature of life, and I have been able to explain that in terms of electrodynamics, and we have been able to build electrodynamic devices that can heal most diseases. We're still working on some, but it's amazing that I would never have thought, for instance, that cancer could be healed by just using some longitudinal radiation. And this was discovered during World War II by a fellow named Anton Prior. And he was drafted out of medical school and assigned to a radar unit. And while he was there, he noticed that the food that was being brought for them to eat was by chance just put at the base of the radar antenna. And he noticed it did not go bad, even if it stayed there for months. Some fruits that people didn't like or care for. And he knew that was unusual. And then one day he walked to a distant army unit and to talk with some friends. And while he was there, he happened to look at their bushel baskets of fruits and vegetables, and he saw they were going bad, that ones that weren't being eaten very quickly. And he mentioned to the people there that they should get their food from the same place his group did because it didn't go bad. And they told him that both of them got their food from the same place, so there was no difference. And so then when he went back, he had an idea that something was coming off that antenna, some electromagnetic form of energy, and that was somehow re-energizing the atoms and molecules in the cells and fruits and vegetables so they didn't go bad. And he asked his commanding officer if he could do an experiment, and he got permission to move the fruits and vegetables 100 yards away from the antenna to see what would happen. And he found that after a few days or a week, it started going bad as he had expected all along. And so his commanding officer told him to move it back so they wouldn't waste their food during the war. And but he knew something was kind of associated with that antenna. After the war was over, he finished medical school, became a veterinarian, and he purchased a surplus radar antenna, and he hired some electrical engineers to tell him what was coming off of that antenna. And they analyzed it, and they told him there were two types of radiation coming off. Transverse radiation, which was what the radar system used, and a small amount of longitudinal radiation, which they guessed was causing the effect on the food. And they proposed to him that they could build him a 2-story building with a large device inside that could produce much more longitudinal radiation that he could test out on different things. So he had them do that, and then he mentioned to them that he was interested in trying it out on sick animals because maybe they could be made better by more energy in their cells. And so they told him that he would need to have them modify it to do a certain frequency ranges so they could get the right frequency for different type of problems. And so they built that for him, and he started radiating these animals, and with their help, he discovered the frequency of longitudinal radiation that would cure 92 diseases that animals get. And he was becoming very popular because there was no side effects. It only took a few minutes, and he was so well known that the people who made Star Trek and Star Wars started including a device which they called the tricorder in the movies, which was based on the science technology that he was developing and what they saw in the future it might be. They thought you could miniaturize it. Instead of needing a 2-story building, you could just do it, with something you hold in your hand. And so anyway, that has come about, and the Chinese are now making a handheld laser that you put a certain crystal in front of, and the light coming out of the transverse radiation coming out of the laser goes into that and comes out as longitudinal radiation. And that is what they are going to be marketing soon to all the world. And the pharmaceutical industry and the medical industry is trying like crazy to stop it from coming because they don't want people to know that just with a longitudinal light of different frequency you can heal most diseases. And many people do not know this, but President Reagan, when he became terminally ill with cancer, his wife took him to Germany and had such a radiation given to him, and he got well in 14 days from being terminally ill with cancer to being well again. So that's another area, and there's all kinds of devices. I manufacture and sell experimental life energy meter on the internet. If you Google it on eBay or just Google it, you'll see a company, Helionosis, that makes it and sells it. And you'll see that you can measure life energy from any living thing, whether it's a bacteria, plant, an animal, anything that's alive. And if you put a leaf, pick a leaf off a tree and put it next to the detector, and you'll tell you how much life energy is in it. And if you just let it wait there and go brown, you'll see the life energy go down to 0. And so that's eventually those experiments are also on the internet. You see videos of them, and they're on the Helionosis website. So there's a lot more to it, and things in terms of health and life itself and the origin of life. So that would be something interesting for you to think about, James, is from your approach, where does life come from, and how do you heal diseases and that sort of thing. Okay, are there any more comments? Okay, if there aren't, I will close the recording, and we will hopefully Franklin will be back next week, and we can continue on our chat discussions. You all have a wonderful day. Goodbye.